With SolidWorks Simulation Professional, you can easily evaluate natural frequencies and their corresponding mode shapes in your part design. Often overlooked, inherent vibration modes in structural components or mechanical support systems can shorten equipment life and cause unexpected failures. We'll begin with a new frequency analysis of the muffler guard used on a small engine. First, let's simulate the thickness of the part with the shell in SolidWorks Simulation. Since the model doesn't have to change, only the thickness entered in the shell will change. We'll save time on meshing and on changes. The material set in our SolidWorks model is used by default, which we will use here. However, we can easily create further studies in SolidWorks Simulation by selecting material from a vast library to pursue alternative design solutions. The guard is mounted using 3 bolts. We will simulate the effects of those bolts using restraints on the 3 mounting hole faces. Now, we get SolidWorks Simulation to apply the shell mesh. This will take less time for shell elements than it would for a solid mesh. To get an idea of how the guard deforms, we can define deformation plots at several natural frequency points. With SolidWorks Simulation, we can easily specify the first 5 natural frequency plots at once to speed up our study. Any of the displacement plots can be animated and exaggerated to show the effect of vibrations on the structure. We can continue with a linear dynamic study on the part, using the same shell and restraints we set for the frequency analysis. A uniform base excitation on the front face will simulate the actual application of 100 meters per second squared. Again, we let SolidWorks Simulation run the simulation and solver. To get an idea of where the part deforms the worst, we will define a response graph. First, we must find the node that best describes the application by looking at the graphics window. And then change the x-axis range down to normal operational levels. This graph shows us where the part is most likely to fail. If we place our cursor on the point, we can read the frequency. Now we can create a stress plot at that frequency to see how high the maximum stress is. As you have seen, SolidWorks Simulation Professional allows you to examine real-world situations on your parts, so you can design parts for optimal cost and maximum lifespan.